Light, it turns out, is a very curious thing. When we start out and try to decide what light is, we very often start by asking the question, is light a stream of particles, like tiny little BBs, only very, very tiny? Or is it possible that light is a wave, kind of disturbance that moves through space? Well, it turns out that light is a very strange thing indeed. But if we start out and ask whether or not it's a wave, we could perhaps play the following game. If we knew what waves do, we could then look and see whether light does the things that waves do, that are very unique and characteristic of waves. And then kind of use the argument, well, if it walks like a duck and it talks like a duck, well, then it's a duck. If it does the thing that waves do, then it's a wave. So let me for a moment tell you a couple of things that are characteristic of waves that are very hard to mimic by a stream of particles. And then we'll ask ourselves whether light does those things. The first thing is called diffraction. Now, this is the idea for a wave, that if a wave moves along and encounters an object, that it will change its direction as it kind of eddies around that object and then move off in a new direction. If you had a second object, perhaps the wave would diffract, kind of bend around that object as well and move in that direction. And if you had two such objects to create a slit, then as the waves moved through the slit, they would spread out behind the slit in both directions, kind of fanning out. Now that phenomenon is called diffraction. And we're going to ask ourselves whether light does that. Let's ask the question whether light behaves like a wave. Does light diffract? And let's imagine that we're going to have a source of light and shine it through a slit. And we would expect that if it was behaving like a wave as it went through this slit, then behind the slit, as it came through the slit, it would then spread out and diffract. Now, there is a rule of thumb that waves have to satisfy in order to demonstrate a significant amount of bending or diffraction. And that is, you have to get kind of a match between the wavelength and the size of the slit. If you have a very short wavelength but a very wide slit, you don't get very much diffraction. It's only when you finally get the slit about the same measure in width as the wavelength of the light that you begin to get a significant spreading of the pattern if it's behaving like a wave. So, I need, it turns out, some very, very narrow slits. I'm going to create a source of light with this laser, a nice, pretty, pure, red light. And then into the path of that light, I'm going to put a very narrow slit. Now, the slits are kind of scratched onto this piece of film. They're very, very thin, thinner than the thickness of a dime. And I have various thicknesses of slits. And so what I'm going to do first is to put into the path of this light, this pure red light, a single slit. And then I'm going to look behind the slit to see whether or not the pattern spreads out. Does it diffract? Then after I do that, I'm going to do it a second time with an even narrower slit. And the rule for waves is that if the slit becomes narrower, once you begin to see diffraction, if the slit becomes narrower, then you ought to get even a broader pattern. So let me put the slit into the path of the light and see what happens. Now let's move it to an even narrower slit. If light is behaving like a wave, then the pattern should spread out even more. So let's move it to a narrower slit and see what happens. Okay. Does light diffract?